Hello and welcome to our lesson on basic triangle proofs. Today we will focus on some fundamental properties of triangles, particularly the sum of interior angles and the properties of exterior angles. Here's what we'll cover step by step. We'll start by defining what is meant by an interior angle and an exterior angle of a two-dimensional shape. Next, we will prove the theorem that states the sum of the interior angles of a triangle is always 180 degrees. Next, we will explore the concept of exterior angles in a triangle and how they relate to the interior angles. Finally, we'll apply these theorems to different examples to reinforce our understanding and see how this knowledge can be used to solve problems related to triangles. In our previous lessons, we've laid a solid foundation by discussing two central concepts. Firstly, how angles on a straight line add up to 180 degrees. With this foundation, we can now delve into the triangle theorems. Let's get started. The first definition we are going to learn today is what is an interior angle. An interior angle of a shape is an angle formed inside the shape by two of the shape's edges. Next, we will discuss what an exterior angle of a shape is. If the side of a shape is extended, the angle formed outside the polygon is an exterior angle. We will now move on to proving some properties of triangles using these definitions. The first theorem which we are going to look at today is that the sum of the interior angles in a triangle always adds up to 180 degrees. This theorem holds for all triangles, no matter whether they are equilateral, isosceles, right angle, or scalene. Their interior angles always sum to 180 degrees. We are going to start by proving the theorem that the sum of angles in a triangle always adds up to 180 degrees. Let's take a step-by-step approach. First, let's begin with the triangle BAC. Now let's construct an additional parallel line to side BC that passes through vertex A. With the parallel line drawn, we create two angles adjacent to angle A. Label these new angles, angle P and angle Q. Great, that's the first two steps done. Now let's move on to our third step. Look closely at the parallel lines and the intersecting lines AB and AC. Notice that angle P and angle B are alternate interior angles and hence they are equal. So angle P equals angle B. Similarly, angle Q and angle C are also alternate interior angles and they are equal. So angle Q equals angle C. Moving on to our fourth step, we now need to consider the straight line passing through A. The angles on this straight line will be angles P, A and Q. Since these lie on a straight line, they must add up to 180 degrees. So we can write that angle P plus angle A plus angle Q equals 180 degrees. In our fifth step, we substitute angle B and C with angle P and Q. Now we get angle B plus angle A plus angle C equals 180 degrees. In this way, we've shown the angles in a triangle add up to 180 degrees. Our next theorem states that each exterior angle of a triangle is equal to the sum of the two opposite interior angles. So in each of these triangles, the exterior green angle equals the sum of the two purple angles. To prove this, let's go back to our triangle ABC. Extend one side past point C to point D. Let this extension form angle ACD. This angle is the exterior angle at C. Recall from previous lessons that supplementary angles on a straight line sum to 180 degrees. Therefore, angle C plus angle ACD equals 180 degrees. We can rearrange this to make angle C the subject. For step 2, we go back to our previous theorem, which tells us that angle A plus angle B plus angle C equals 180 degrees. Substituting angle C into our equation, we get the following. Finally, we can rearrange this by subtracting 180 degrees from each side and adding angle ACD. Here we get angle A plus angle B equals angle ACD. This shows that the exterior angle ACD equals the sum of the opposite interior angles, namely angle A and angle B. Using these proofs, we've established that the sum of the interior angles of any triangle is always 180 degrees, and that each exterior angle is equal to the sum of the two other interior angles. These properties are fundamental in solving many geometric problems involving triangles. Let's now see some examples of this in action. Let's now apply this knowledge to some problems. Imagine you were given a triangle with two known interior angles, 50 degrees and 60 degrees. We need to find the third angle. Pause the video here and see if you can solve this. Firstly, we need to recall that the sum of the interior angles in a triangle is always 180 degrees. Let's denote the third angle as x. According to the theorem, 50 plus 60 plus x equals 180. Now let's solve for x. Firstly, let's simplify this equation. 50 plus 60 equals 110. Now we can rewrite what we have as 110 plus x equals 180. The next step is to rewrite this in terms of x. To do this, we subtract 110 degrees, getting x equals 180 minus 110. Then we simply have to do the maths. 180 minus 110 is 70, and therefore x, the third interior angle, is 70 degrees. Now let's look at how exterior angles work. Consider a triangle where one of the exterior angles is 120 degrees. We know that an exterior angle of a triangle is equal to the sum of the two opposite interior angles. Here, the exterior angle is 120 degrees. Therefore, the two interior angles opposite it must add up to 120 degrees. Let's call the two interior angles A and B. So, A plus B equals 120. If we know one of the interior angles, we can easily find the other. For instance, if A equals 70 degrees, then we can substitute this into our equation. 70 degrees plus B equals 120 degrees. Therefore, B equals 120 minus 70. Solving this, we get that B equals 50. Thus, one of the opposite interior angles is 50 degrees. Let's combine both theorems in a slightly more complex problem. Suppose we have a triangle with interior angles 40 degrees, 80 degrees, and an unknown third angle y. Additionally, we need to find the exterior angle adjacent to the unknown angle. First, let's find y using the theorem that angles in a triangle are 180 degrees. We can write that 40 plus 80 plus y equals 180. Simplify this to 120 plus y equals 180. Then finally that y equals 180 minus 120, which equals 60. So we know that y equals 60 degrees. Now we need to find the exterior angle adjacent to y. Remember, interior and exterior angles on a straight line add up to 180 degrees. Therefore, the exterior angle must equal 180 minus ya. Substituting in 60 degrees for y, we can write that the exterior angle equals 180 minus 60. Doing the subtraction, we then know that the exterior angle equals 120 degrees. Therefore, the exterior angle adjacent to the 60 degrees interior angle is 120 degrees. Alternatively, you can use the exterior angle theorem to find the green exterior angle. This theorem says that each exterior angle of a triangle is equal to the sum of the two opposite interior angles. Hence, the exterior angle is equal to A plus B, so 40 degrees plus 80 degrees, which gives us 120 degrees. By working through these examples, you can see how the sum of interior angles and the properties of exterior angles in a triangle are fundamental tools we use in solving various geometric problems. Feel free to refer to the provided diagrams to visualize these concepts better. In today's lesson, we explored two fundamental theorems related to triangles. First, we established that the sum of the interior angles of a triangle is always 180 degrees. We demonstrated this by constructing a parallel line through one vertex and using alternate interior angles to show that as the angles on a straight line sum to 180 degrees, the angle A plus angle B plus angle C equals 180 degrees. Next, we examined the properties of exterior angles in a triangle, specifically proving that each exterior angle is equal to the sum of the two opposite interior angles. By extending a side of the triangle and using the concept of supplementary angles on a straight line, we showed that angle ACD, the exterior angle, is equal to angle A plus angle B, the sum of the two non-adjacent interior angles. These theorems are crucial for solving various geometric problems involving triangles. Understanding these properties allows us to find unknown angles and simplifies many aspects of geometric reasoning. By mastering these concepts, you are well equipped to tackle more complex problems involving triangles and other two-dimensional shapes.